Today I'm going to be teaching about related rates in calculus. Now they're a little confusing. Um, so what are related rates? They're like the rate at which things are changing when and you typically have to relate them to other rates. So you have to get an equation like the formula for a triangle, and you have to relate the rate of the base changing, because triangle's area equals 1/2 base times height. You have to relate the rate of the base changing to the rate of the area or the height. So it'd be like you have to know how to do implicit differentiation, kinda, where you like a y squared equals x squared would actually be an implicit differentiation. It would be 2y dy dt equals 2x dx dt. So you have to do that, and then you plug in the rates for the things instead of you have to plug in the rates after you take the derivative, and then solve for whatever you're looking for. And two examples of this are a ladder falling down a wall. It creates a right triangle, but it's falling down a wall, so the bottom. Wait, I can turn on a mouse. Oh yeah. The bottom. It would be going to the right, so that the rate of the base would be increasing, and the rate of the height would be decreasing. And water, like a weirdly shaped cup, like a cone cup would the radius is increasing, the height's increasing as more water gets added, or if water's removed, then they're decreasing, and you have to solve that. So, how do you know when to do them? Typically, it'll give you a lot of nonsense information, but none of it's nonsense. It just gives you a lot of information, and it'll ask you to calculate the rates of some variable, like the area or the height, or one of those. And yeah, so some useful tips that I find useful. You gotta draw out a diagram of what the question is asking for. So if it's asking for a circle or a sphere or a triangle or a ladder, a drawing is very useful to help get your thoughts together. And you're gonna have to memorize a bunch of stupid equations that you shouldn't have to memorize. I don't know. A pyramid is 4/3 pi r cubed or something like that. I don't know. No, that's a cone, maybe. I don't know. It's something like that. And cylinders, you have to just memorize a ton of area formulas, or sometimes you're gonna use Pythagorean theorem, or the relating related triangle formula. And last tip is to write down everything that the question gives you, because it's all important. Every single rate, everything, and write down what you're looking for. Put a question mark next to what you're looking for, because it'll help get your thoughts together. And write down a formula that keep thinking about the possible equations that you could be using in any given circumstance. So let's do a practice one here. This is a little scuffed. It's okay, hopefully. Okay, I'm read this. So the radius of a circle is increasing at a rate of 3 centimeters per second. Find the rate at which the area is increasing when the radius is 5 centimeters. So, to draw this out, you've got a circle. The radius is increasing. So it's like increasing at 3 centimeters per second. Boom. And we're looking for the rate at which the area is increasing when the radius is equal to 5 centimeters. So radius equals 5 centimeters. The rate at which the area is changing would be dA dt, because the area is changing over time, and we don't know what that is. That's what we're looking for. And the rate that the radius is changing is dr dt, and that is that's increasing, so it's positive 3 centimeters per second. My hand's already starting to hurt. It's okay. This is visible. Find the okay. Now finding a formula for a circle. So the area of a circle is pi r squared. You just have to memorize these things. Like this is like the hardest topic of calculus, but if you just know your formulas, it's not that bad. And this was simple anyway. So then you take the derivative of this. The derivative of this whole thing with implicit differentiation would be dA dt equals, you take the 2 down, 2 pi r dr dt. So now we know what r is, we know what dr dt is. You cannot plug in this 5 before you take the derivative. You have to do it afterwards. You cannot do it beforehand, because that like messes it up. I don't know why, it just does. Like, it just doesn't work. I mean, yeah, I don't know. Because then you're not really like you wouldn't be using the rate of change of the radius, I guess, so, and that's important. So dA dt equals 2 pi 5 from the r times 3 centimeters per second. Centimeters. And this would be, so 5 times 3 is 15, times 2 pi is 30 pi centimeters squared per second, equals dA dt. Boom. Nice and chill. So the rate at which the area is increasing when the radius is 5 centimeters is 30 pi centimeters per second. Okay, now different type of equation, different type of question. A particle moves along the curve y equals x squared. If dx dt equals 3 when x equals 2, find dy dt at that point. So this one's pretty simple. It's going with a curve here instead of a actual thing. So they literally give us the equation we have to use. We don't have to know anything. So taking the derivative or implicit differentiation of this would be y equals x squared. So it would be dy dt equals 2x dx dt. And we know dx dt, and we know 2, or we know x. So it would be dy dt. Jeez. I'm kind of have to multitask here. Dy dt equals 2 times 2 times 3. So it's a nice, easy little 12. Equals dy dt. Okay. We'll do like one more, because I guess I yapped for a little bit too long. I'll do it quick. Okay. Which one? We'll do this last one. So this one's pretty hard, but it's not that bad. So a man 6 feet tall walks oh. What does that say? What did I write? A man walks away from a wall at 4 miles per hour, or a street light, a lamp, a wall lamp, from a street light that is 15 feet high. How fast is his shadow lengthening? So this would be a triangle, because a street lamp casts a shadow from his height. He's 6 feet tall. This is the guy's height, and the street lamp is 15 feet tall, and it's casting a shadow. So how fast is this increasing? We're gonna call. So we're gonna call this y, and we're gonna call this right here. This whole thing would be x plus y. We're just gonna say. I'm going over. I'm sorry. I went over time. I talk too much. Please be kind. So a formula to use here would be the relation of these two circles. They're similar, so we can use 15. Or okay, so it would be this over this is the same as this over this because they're related. 15 over x plus y equals 6 over y. Now, yeah, and like this would be the. I think this is dx. Yeah, this is dx dt. This dx dt is 4 miles per hour, and yeah, the height is. We don't need to write that. They're already there. Sorry, I didn't show it. Now cross multiplying, we get 15y equals 6x plus 6y, and then bringing this over, we get 9y equals 6x, and then if we take the derivative, it'd be 9 dy dt equals 6 dx dt. Now, we know this is 4. So 6 times 4 equals 9 dy dt. This would be 24. 24. And then divide by 9. Dy dt equals 24 over 9. Kaboom. Oh my goodness. It's 24 over 9. It's like, that's, simplifying, that's 8/3. Is the rate at which the shadow's length is increasing. I hope that showed